Greetings and welcome back to another episode of Transformers, Algebra 2 edition. In this section, we are going to be transforming functions. We've transformed functions before. We've transformed lines, absolute value functions, quadratic functions, polynomials, exponentials, logarithmic, rational, radical. We've transformed a lot of functions before. This is just kind of the recap of transforming functions. We will be taking a look at piecewise functions, since those are new. But other than that, there's really nothing new here. And this is really the last time we're going to be talking about transformations this year. I know you're sad. Try to control the tears. It'll pass. We'll get through it. Maybe we'll bring transformations back just for a visit. But this is the last transformations topic. Next chapter we'll talk about them just a little bit, but kind of in the topics just to see how things happen. But we won't be talking about functions, so it'll be different. Anyway, learning targets today. I can transform functions. Yeah. Also, I can recognize transformations of functions. The same stuff we've been doing. Do this transformation. What transformation just happened? So, looking at our transformations, remember we have the three big ones: translations, stretch compressions, and reflections. Each of them has horizontal and vertical components. With translations, we're adding and subtracting. So, g of x is f of x minus h. For horizontal and vertical, g of x equals f of x plus k. Remember horizontal, this means we're replacing the x with x minus h. And the vertical means we're just adding k to the end of the function. Stretches and compressions, horizontal, f of 1 over b times x. Remember, it's backwards, just like this is minus h. And again, we replace the x with the 1 over b times x. Vertical, we just multiply the function by a number. And then reflections, horizontal, across the y-axis. We make the x negative, replace all the x's with negative x's. And vertical, we just make the function itself negative. And vertical would be across the x-axis. So, we need a piecewise function to do some transformations with. Let's use f of x equals 2x plus 1 if x is less than negative 1, x squared if negative 1 is less than or equal to x is less than 2, and 3 if x is greater than or equal to 2. This gives us a line, a quadratic, and a constant function to look at. So, translations, we can move it 1 unit left and 2 units up. So, g of x will equal f of x plus 1 plus 2. So, all of the x's will change to x plus 1s. And then we just add 2 to the end of the function parts. So, we can take our f of x and change it. So, 2, x plus 1 plus 1, that's that plus 1. And then plus 2. Notice the domain. I said all the x's change to x plus 1s. This is the part about the piecewise functions that people forget. Even the domain changes to x plus 1. Notice the plus 2 doesn't matter. The domain is only talking about x values. So only horizontal transformations will change the domain. This x plus 1, x changed to x plus 1 plus 2. And 3 plus 2, there's no x plus 1 here, but there is 1 here. We can simplify the 2x plus 2 when we distribute. Plus 1 plus 2 will be 2x plus 5. This I just leave as x plus 1 squared. If you really want to, you can distribute that to be x squared plus 2x plus 1, and then plus 2. And then 3 plus 2 is just 5. The domain part, we just need to subtract 1. So that becomes negative 2. Here, technically we need to split it into two pieces. Negative 1 is less than or equal to x plus 1, and x plus 1 is less than 2. But we can actually just do it here. When we subtract 1, we have to do it to both of them. So this will be negative 1 minus 1 is negative 2, and this will be 2 minus 1 is 1. And here subtract 1 to get 1 again. So we end up with 2x plus 5 if x is less than negative 2. X plus 1 squared, there should be a plus 2 here. Apparently I can't see that green 2. Should be x plus 1 squared plus 2 if then the negative 2 and 1 because we subtracted 1 from both of them. And then 3 plus 2 is 5 if x is greater than 1. So that's stretches and translations. Next piece, stretches and compressions. We'll do a vertical stretch of 2. It's so g of x equals 2 times f of x. It's vertical, so we'll multiply it to the function. The function is just this part, not the domain, just the function. So g of x equals 2 times 2x plus 1, 2 times x squared, and 2 times 3. The domain will stay the same. It will only change for horizontal transformations. Distribute the 2 to get 4x plus 2, 2x squared, and 6. And then again, the domain stays the same. If we have a horizontal stretch of, say, 3, this one will change the domain because we're going to take all of our x's and we're going to replace them with 1/3 x. So when we take it, we replace with 1/3 x, replace this one with 1/3 x, replace with 1/3 x, replace with 1/3 x, and replace this one with 1/3 x. It's fine. Here we'll distribute to get 2/3 x plus 1. This one we can square both pieces, 1/9 x squared. And then over here, to get rid of the 1/3, we just multiply by 3. So this will be negative 3, and 6. And this will be 6. And so we get that. Something to notice, in the original function, we get to negative 1 to 2, and then from 2 on. Notice there's no gaps here. These two numbers are the same. These two numbers are the same. Even after we do our transformation, these two numbers are the same. 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 We're not going to create a gap in our graph by doing these. So it's a good check just to make sure that, hey, these are actually still the same, and these are still the same. Let's do a reflection. A vertical reflection across the x-axis is just going to make things negative. You can just imagine this 2 is a negative and just go from there. We're going to look at a horizontal because it does do something kind of weird when it flips things. So a reflection over the y-axis means that g of x is going to become f of negative x, which means we change all the x's to negative x's. Those guys plus all of these. So this will be a negative 2x. Negative x squared is just x squared. That stays 3. Now here, though, when we divide or multiply by negative 1 to get that negative across, this becomes 1, and what else happens? That's right, when you multiply or divide by a negative, you have to flip the sign. So this will become x is greater than 1. This will be 1 is greater than or equal to x, which is greater than or equal to negative 2. And this is x is less than or equal to 2. Now, this middle one, we don't like having it that way. We want the arrows pointed the other direction, so we're going to flip the whole thing around. It'll be negative 2 is less than x is less than or equal to 1. Other than that, we could leave it, but it's nice, like just as tradition, to have the smallest one on top. So the x is less than or equal to 2 is now the smallest, so it goes on top. And the x is greater than 1 is now the biggest, it goes on bottom. Because when we take something over here on a graph and we flip it over here, all of a sudden the biggest stuff becomes the smallest stuff, and vice versa. So usually we would take this bottom one and move it to the top, and take the top one and move it to the bottom. And then notice this middle one, we want the arrows all pointing to the left. So negative 2 is less than x is less than or equal to 1. And that does it. That's the reflection. That's transformations. There's really nothing new here. It's just with Piecewise, you do it to everything, and the horizontal stuff also changes the domain. You're also going to be seeing a couple things about the intercepts. Horizontal things will change x-intercepts. You do the same thing. If you stretch by 3, you're just going to multiply the x-intercepts by 3. The vertical intercepts will change with a vertical translation. Y-intercepts change with vertical transformations. So there's that. And some of them, like a vertical translation, will also change the x-intercept, but not in a way that's necessarily predictable. So we're only going to be looking at things that are predictable like that. Anyway, last topic on transformations. I know we'll get through it, but it'll be okay. Anyway, I'll see you in class so you can do a couple problems. And until then, enjoy.